Okay, let's look at question number 25. Two kitchen chicken coops are to be built adjacent to one another from 120 feet of fencing. What dimensions x, y should be used to maximize the area of an individual coop, and then what is the maximum area of an individual coop? Okay, so what you need to realize is because you have three of these, you have 3y, and because you have 1, 2, 3, 4 of these, you have 4x. Okay, and those would be the pieces that would have to add up to 120 feet of fencing. So that's our first equation. Now the second one is area. So again, we know that the bottom part is 2x, and we know the vertical part is y. Area of a rectangle is length times width, or base times height. So we're just going to get 2x times y, and all of this is going to equal to the area, which will change depending upon our dimensions. So what do we do here? Well, let me rewrite these equations again. So we have 3y plus 4x equals 120, and area is equal to 2xy. All right. So what I'm going to do is I'm going to get one of these letters by themselves on the left side and substitute it back into the right side. So I'm looking at this, and it doesn't really matter so which one I get to be what. So let me just subtract 3y from both sides. So I get 4x equals 120 minus 3y. Divide through by 4. X is equal to, now 12 divided by 4 is 3, so 30 minus 3/4 y. So there's a value of x, and now I can plug it back in there. So that gives me area equals 2 times 30 minus 3/4 y times y. And we'll clean this up, so we'll distribute the 2 into both of these, and we'll get area equals to 60 minus 3/2y times y. And just to be clear here, 2 times 3/4 is the same thing as 2 times 3/4, like so. And because the 2 and the 4 are under each other, you can divide. It gives me 3/2. So, okay. So from here, what I'm going to do is distribute the y. And I get area equals 60y minus 3/2 y squared, which I'm going to rewrite as area equals negative 3/2y squared plus 60y, just switching the order. Now, if you recall, there's a formula we learned, which is x equals negative b over 2a, which refers to the x component of the vertex. I'm going to take this value, and I'm going to use this formula with these as a, b, and then c here is just going to equal to 0. We don't have a c value, but c would be 0, so it's like plus 0. And the reasoning behind this, the intuition behind this, is that what we end up getting with the area equation, with this equation right here, is a parabola that's upside down. So we know that we have this. And the reason why we know we have this sort of parabola is because the a value is negative. So that means you have it just upside down. What we're looking for is the highest point, and the highest point would be wherever the vertex is. So what I'm essentially looking for is the vertex. So anytime you see a question that asks you for the max area, or is talking about the maximization of the area, usually for algebra in algebra K classes, you're usually going to be finding the vertex. Okay, so what do I do from here? So I use negative b over 2a, so that's going to be negative 60 over 2 times negative 3 over 2. And I know that looks ugly, but it's really not that bad. Okay, negative and a negative becomes a positive. So you have 60 over 2 times 3 over 2. And then the really nice thing is that because you have 2, which is 2 over 1, because you have 2 above and below, you actually end up just getting 60 over 3, which is 20. Okay, so what do we calculate? We now know that the x component is 20. So in this picture, we know we go out 20. But what we don't know is how high it is. And remember, the height here, this component here represents the y value, right? And what we're looking now for is what this equation is equal to, which is the area. So the first thing I'm going to do is, if I know my y value, why don't I just substitute this equation to find my x value? So we'll do the math here. So this gives me 3 times the y value, which I forgot already, is 20, I think. 20. 3 times 20 plus 4x equals 120. So 60 plus 4x equals 120. 4x equals 60, and x is 15. And hopefully at this point this is clear, but if it's not, I subtracted 60 from both sides and then divided by 4. And I got 15. Why did I need 15? Well, I need my x value to be 15 and my y value to be 20, because with those two values, I can plug them in here and find the area. So let's do that in brown. So the maximization of the area is 2 times 15 times 20, which is going to be 2 times 15 is 30. 30 times 20 is 600. And that is my max area. Okay, so again, what we did was we created these two equations initially in order to figure out what A is. I isolated a variable. In this case, I chose x. You could have chosen y. It doesn't matter. We substitute it back into the area equation. And that derives an area equation. A equals 60y minus 3 over 2y squared. I use negative b over 2a to calculate my y value. It's a little confusing, but use that to find the y component, which we then used to plug back into the original equation to get an x value, which was 15. And with those two values, then I can use my secondary equation, this one right here, and calculate the max area. So let's make sure we answer the question. Let me erase some of this. The question is, let me do it in red. What dimension x and y would give the max area? That's 20 and 15. Actually, it's the other way around. It's 15 and 20. And what is the max area? 600. So hopefully that makes sense, and I'll see you in the next video.